Okay, so today we will discuss a very interesting, very important also, 3 laws, only just 3 laws which are highly useful. See, first thing is Avogadro's law. Yesterday I have given you some clarity on this already. Okay, Avogadro's law. Okay, first thing, and the next Gay-Lussac's law. Law of combining volumes. Combining volumes. Okay, and more interesting thing is there is a special type of calculations. Generally what we will do, stoichiometric calculations means we will balance the equation and we will do simplification, calculating how many moles of product formed this now. So today I will tell you one very important method that is called POAC method, like principle of atom conservation. Principle of atom conservation. So this is very basic and it is based on law of conservation of mass. On what? It is based on law of conservation of mass, and you know this law of conservation of mass you are already aware from basic classes onwards, from like 8th, 9th, 10th itself you are studying about law of conservation of mass. Okay, now once after learning this principle of atom conservation, without balancing the equation, without struggling to do all that stoichiometric calculation, you can easily do any type of question. Most of the questions will be done on this. Okay, we will see all these questions. Okay, yeah. First thing, okay, let's see. First one, what do we studied about Avogadro's law? Tell me. Law. Yeah. So I told you, like, yeah. So it equal, first of all, basic understanding. Then next, the conditions. At similar conditions. Conditions of temperature and pressure, the equal volumes of any gas contains same number of gaseous molecules, It is nothing but moles also we can say. It means volume is directly proportional to N at constant temperature and pressure. So this is a basic formula and a kind of thing to be remembered. Okay, it means I have a gas, like let us say gas 1 is there, we have gas 1 and gas 2. Okay, so for gas 1 volume is V1, for gas 2 volume is also V1. Okay, then in this V1 volume gas gas 1 molecules are around some 10 lakhs. Then how many are there in this V volume of gas 2? How many G2 molecules are there now? Same, because volume is directly proportional to N now, so you can write V1 by V2 is equals to N1 by N2 also by removing proportionality. Okay, so I hope you got some clarity. So if gas 1 or gas 2, any gases you take with equal volumes, they contains equal number of gaseous molecules. Let us say gas 1 is having 100 liters volume and gas 2 is also occupying 100 liters volume only. Okay, in this 100 liters, let us say there are 10 crores of gas 1 molecules. Okay, then gas 2 molecules also 10 crores only, because same volume now. This story applicable only at constant temperature and pressure. This should be clear. Okay, done up to here? Yeah. So now Avogadro observed that, there is some experimental observation here. So what he considered is, he taken 1 mole of gas particles, 1 mole of gas particles. So these 1 mole of gas particles are occupying 22.4 liters at NTP conditions. At NTP condition, what is the volume occupied? 22.4 liters, 1 mole of any gas, 1 mole of gas. At what condition? It must be NTP. So NTP means, yesterday I told you, normal temperature and pressure, like 0 degrees Celsius, 1 atm pressure, 1 atm pressure. So at that condition only. Sir, what if I change the temperature and pressures? If you change these values, here the volume occupied also changes, or quantity also changes. Oh, okay, that's why these fixed quantities are important thing. Okay, right. Next, if 1 mole of gas is occupying this much, then half mole occupies 11.2. 1 by 4, like see, 1 mole is this much. 1 by 2 mole means, you just remember these numbers, 11.2 liters. 1 by 4 mole means again by 2, that is 5.6 liters. Just remember these numbers, we may see them in the questions. Okay, these 3 numbers are perfect. Next, if I say 2 moles, 44.8, like that we can calculate. Clear up to here? Okay, let us see one question on this. Good morning. Perfect. Okay, so now let us see some questions on this. I am saying a question like this: 28 grams of N2 gas is present at NTP. Calculate volume occupied, volume of the gas occupied at this condition. Shepherd, what is your answer? So 28 grams of N2 is nothing but number of moles of N2 you calculate first. Number of moles is given weight by molar mass. What is the molar mass of N2? 28. So this will be 1 mole. So 1 mole occupies how much? 1 mole of any gas, it will be 22.4 liters at this NTP condition. Clear? Okay. So instead, if I say 14 grams of N2, 11.2. 7 grams of N2, 5.6 liters. Okay. Now I just wanted to make some clumsy kind of question. Okay. So 28 grams of N2 is present in a container at NTP, occupies some volume. So if the same volume of methane is also present, then what is its weight at NTP? Very simple, just a confusing kind of question. Yeah, that is also 22.4 liters only now. So 22.4 liters is nothing but 1 mole of that gas, whatever the gas they mention, that is methane gas. So methane gas 1 mole means what is its molar mass? 16, like 12 plus 4, 16 grams. That's it. This is your final answer. Is this clear, everyone? Okay, next. Amrita, someone, yeah, you just keep on answering. I will be giving few more questions here. Next. So this is clear now. Next. .6 liters of O2 present at NTP. Find number of oxygen atoms. You should connect it to yesterday's class, like mole concept class. Tell me. Very simple. So those who are in the live, you can answer your answers. I mean, you can mention your answers in the chat box. I will be looking into it. Okay, so no worries even if it is wrong. You just mention in the comment box. Okay, done. Is my question is clear? What I am asking, 5.6 liters of O2 present at NTP, find oxygen atoms. First, 5.6 liters of O2 at NTP means how many moles it is? 1 by 4. Just now I told you that value is given. Okay, so if you are not getting this, I told you how to find number of moles is equals to given volume by 22.4 liters. So given volume is 5.6 liters. So this is 1 by 4 mole. Up to here it is clear. Okay. So 1 by 4 mole. 1 by 4 mole means we have 1 by 4 mole means 1 by 4 into Na number of oxygen oxygen molecules. But now I am not asking molecules, we are talking about atoms. So one molecule contain, one O2 contains how many atoms? 2, but because atomicity of oxygen is 2. So one molecule of oxygen contains 2 oxygen atoms. How many oxygen atoms? 2. So it is simply, you can write 1 by 4 into Na into atomicity of that element, whatever I am speaking about. So 1 by 4 into Na into atomicity of oxygen is 2. So this will be 2 times. So 1 by 2 into Avogadro number, that is 6.022 into 10 power 23. So this will be 3.011 into 10 power 23. That's it. Clear? Okay, you want to do one more question on this? Yeah. Next. Yeah. Next question you can write. (0.112 liters of H2 is present at NTP. Calculate weight of H2. So guys, those who are in the live session, who join now itself, you just stay till the end. You are going to learn very interesting and very important thing. Like at last I will be discussing POAC method, which is highly useful to calculate all types, like without balancing any chemical reaction you can do all mole concept type questions. Okay, just stay connected with this. Yes. Done? Given volume at NTP is this much. So given volume by 22.4 gives you number of moles. First find number of moles. (22.4). Yeah. So just adjust the decimals. Like it is 22.4. Can I write it as 11.2? If I write 11.2, you should write it as 10 power minus 2 into. So write like that. 11.2 into 10 power minus 2 divided by 22.4. Okay, how many times 11.2 is 22.4? So you got it as 1 by 2 into 10 to the power minus 2, right? Okay, this many moles you got. Okay, perfect up to here. Next, what they are asking, weight they are asking. So moles we got. What is the relation between weight, number of moles and molar mass?
Number of moles is equals to
given weight
by molar mass.
Perfect. Use that and simplify. Okay. So what I can do? calculate weight of H2. So first find number of moles of H2, that is given volume by 22.4 liters at NTP condition only. Okay, so this will be something like 11.2 if I write. So I can write 11.2 into 10 power minus 2. So 11.2 2s up. So 1 by 2 means 0.5 into 10 power minus 2. 10 power minus 2. Up to here it is clear. Number of moles we got. Number of moles is equals to given weight by molar mass. From these, weight is equals to number of moles into molar mass. So number of moles are 5 into 10 power minus 3 I can write. Molar mass of H2 is 2. 5 2s are 10. So 5 2s are 10 means 10 into 10 power minus 3 is there. This many grams we got. I can write it as 10 power minus 2 grams or 0.01 gram of H2. Is this clear? Yeah. Now the same question can be extended forward as number of N2 molecules. H2 molecules. Number of H2 molecules. Simple, you can answer that. Yes, any answer? First of all, number of moles we got now, that's fine. So after getting this, number of moles of hydrogen into Avogadro number gives you number of molecules. Okay, so that is 5 into 10 power minus 2, or you can write 1 by 2 into 10 power minus 2 into Avogadro number 10 power 23. So this is 3.011 into 10 power 21. Okay, this is about number of hydrogen molecules, H2 molecules. Now even if I ask atoms, what is your answer?
6.02.
So one molecule contains 2 hydrogens now, atomicity is 2. So this many molecules into 2. So that is 2 into 3.011 into 10 power 21 hydrogen atoms. This could be your answer if I say atoms. Okay, is this clear or not? Okay, I hope you got complete clarity like what kind of questions we can expect. Okay, if not, you please write this. Shopping Wally, what you are asking? How are you, sir? I am fine. Yeah, done? Okay, next one what I told you, Avogadro's law is done. Next one is Gay-Lussac's law of combining volumes. So there is one more Gay-Lussac's law we will study in gaseous states of matter, that is different. Here we are studying about Gay-Lussac's law of combining volumes. Okay, so what it says, so when we are writing a balanced equation, let us say H2 plus Cl2 gives rise to HCl. So it is 2HCl. Now see the things involved here, reactants are gases, products, all the things are gases only. Now what I am saying is Gay-Lussac's law of combining volumes applicable only for gaseous reactions. Which one? I mean gaseous components, like it should be gas. If there is something liquid here, don't apply Gay-Lussac's law to that, apply only to gaseous things. Okay, and this Gay-Lussac's law is applicable at a constant temperature and pressure. Okay, this is something like we have derived this Gay-Lussac's law. The basis for Gay-Lussac's law is our Avogadro's law. That is what you need to remember. So now generally if I write a reaction in this balanced equation, what are the stoichiometric coefficients you are seeing? 1, 1, 2. So I can simply say 1 mole H2 reacting with 1 mole chlorine forming 2 moles of HCl, like this we can say. In case of gases, like just now we discussed, volume is directly proportional to number of moles. Instead of saying moles, I can also say in terms of 2 volumes, I mean 1 volume. So I can say 1 volume, this as 1 volume, this also as 1 volume. Don't say 22.4 liters. Why? I am not discussing it NTP condition. Did I mention NTP here? I just told you constant temperature and pressure, not NTP. Okay, so if I say NTP, you can take 22.4, all the things, but at any constant temperature and pressure, volume is directly proportional to moles. Instead of writing 1 mole, I can also say it as 1 volume. So what do we mean by 1 volume here? So it is nothing but like 1 liter H2 react with 1 liter Cl2 forms 2 liters HCl. Like this you can understand. Is this clear what I am saying? Okay. For example, I got 20 ml of HCl. What should be the ratio here I should take? 10 ml of H2, 10 ml of Cl2 gives you 20 ml of HCl. Is this clear or not? Very basic understanding. Okay, right. Next. Okay, this is about the thing. Now let us do one question here. Methane undergoes combustion, complete combustion, produces CO2 plus H2O. Okay. Generally, they simply mention it as 25 degrees Celsius and 1 atm pressure. Okay. So at this condition, what is their physical states? Methane is a gas or liquid or what? Methane at this 25 degrees Celsius means room temperature. Methane is a gas. So mention it as gas, physical state. Oxygen gas, CO2 gas, water liquid. Done up to here? Okay. So now Gay-Lussac's law applicable only for gases. Next, is this a balanced equation first? No, first balance it. So 1 mole methane combines with oxygen to form 1 mole CO2 plus 2 moles oxygen. So how many moles of 2 moles water? So 2 moles oxygen is required. So what is the volume ratios I can say here? Like 1 volume of methane requires 2 volumes of O2 forms 1 volume of CO2. I should not say this 2 volumes of water because it is a liquid. Liquid won't be connected here. Avogadro's law applicable only for gases. So don't include that. Is this clear? Gay-Lussac's law is also applicable only for gases because I told you Avogadro's law is the basis for Gay-Lussac's law of combining volumes. Clear or not? Okay, done. Up to here it is done. Yeah, next. We will see questions after some time. Next one I told you, we will be discussing interesting thing, that is POAC method. Okay, yeah. Before this, let us say I have 16 grams of methane. How many grams of methane? There is 32 grams of methane. Next, tell me weight of CO2 formed and weight of water formed from this 32 grams. Yeah, just do this. Any answer? So just normally stoichiometric calculation is what we'll do. So 1 mole H2 see methane giving you 1 mole CO2, right? Okay. The next 32 grams of methane means how many moles it is? 2 moles. So 32 by molar mass of methane is 16. So this is 2 moles. Then 2 moles of methane gives you 2 moles of CO2. 2 moles of CO2. So 2 moles is nothing but weight they are asking now. So 2 into what is the molar mass of CO2? 44. This is 88 grams. Clear up to here what I am doing? Okay. So in the same way you calculate this, then I will tell you POAC method. Now I am not connecting them with the volumes. I am just asking their weights. So here no worries, you can connect. Okay. So you can say 1 mole, 2 mole, 1 mole, 2 mole. So see, for 1 mole of methane we are getting 2 moles of H2, water. Then for 2 moles it should be double. So 4 moles of, like Seema, for 1 mole of methane we are getting 2 moles of water. Then for 2 moles of methane we will get 4 moles of water. So 4 into that number, 4 into 18 molar mass. So this is the weight of water produced. So it is 72 grams. Clear? Okay. Now here we are doing this concept, calculation with respect to balanced chemical equation. Now I will do this without balancing the equation. See, CH4 plus O2 gives rise to CO2 plus H2. Did I balance this equation? No. Now what is my question? Weight of CO2 produced and water produced from 32 grams of methane. So without balancing we will do this. Firstly, we know during a chemical reaction total mass of reaction is conserved, like law of combinations, like we studied about that, law of conservation of mass. So what it says, whatever the mass we have reactant side, that should present at the product side. Okay. So now mass of carbon here, if it is 12, this side also mass of carbon should be 12. For example, mass of hydrogen, if here it is 4, that side also it should be 4. It means during a reaction the total atoms are also conserved. What I am saying, total atoms are also conserved. So how many carbon atoms reactant side? 1. Product side also should be 1. How many hydrogens this side? That side also it should be 4. This is clear now? Very basic. Okay, right. So based on this clarity we can use POAC. Now what is my question? Weight of CO2. How much I am asking? So CO2 is this side now. So I can say number of moles of CO2. How many carbons are there, ma? Okay, because data is provided for methane now. So data provided for methane means the data belongs to carbon also, right now? So in methane how many carbon atoms are present? 1. So 1 into number of moles of methane I am writing, because how many carbons are there? 1. That's why 1 into number of moles of methane. This side how many carbons are there in CO2? So 1 into number of moles of CO2 I should write. So this writing part is there now. This is called PO, applying principle of atom conservation on carbon atom. Which atom is conserving we are doing in this reaction? We are conserving carbon atom, right now. So that's why number of carbon atoms 1 I told you, here 1 into number of moles of methane. This side also 1 carbon is there, 1 into number of moles of CO2 I written. Next, what is my question data providing here? 1 into, what is the weight I given? Methane weight 32 grams in the question, right? So that is given weight 32, molar mass of methane is 16, which is equals to 1 into, if I ask number of moles, directly you can do like this. If I ask weight, you can write weight by what is the molar mass of CO2? 44, that's it. So everything we got. See, this will be 2 times, so 44 into 2, 88. So even you do like this or in this way, both are giving same answer, but this is easier method. some cases, not all cases, but most of the cases. But most of the students will follow only this. Okay, so now what I suggest you is you be clear with both the things. Whichever is convenient at that particular question, we follow that. Okay, now tell me how to do for water calculation. How to do for this water calculation? Means water is formed with the help of hydrogens, right? No, so hydrogen atoms, where do we have here hydrogen? Don't worry about this, we have only here. So apply POAC of hydrogen atoms from this. So how many hydrogen atoms are there? So that is 4 into number of moles of methane. I should write like this, equals to how many hydrogen atoms in water molecule? 2 into number of moles of H2. Clear? Okay. Next, 4 into what is the weight of methane given? 32. Molar mass of methane? 16, which is equals to 2 into number of moles of water. Okay. Next, what I can do? This will be 2 times. So 2 cancelled. So how many moles of water we got finally? 4 moles. So I don't want moles. If I want water, weight by molar mass of water is 18. So weight will be 4 into 18, that is 72 grams. Same answer we got in the previous method also. Okay, so both methods are good, you can use this. See, I will only say when to use these methods. If the equation is very small, like methane, ethane, small equations are given, then you use balanced equation. But sometimes very big equations will be given, that balancing only taking more time, then that case don't balance, use POAC method if possible. Okay, yeah. So now I will give you some questions like that. First you just mention this in your notes, both methods you mention. First write this. This is based on normal gravimetric calculations, or you can say stoichiometric calculations. Done? Write this also. Yeah. So now I just wanted to increase the question size. So C4H10 O2 undergoing combustion produce CO2 plus H2O. Now the question given is like this. "26 grams of butane is provided." Butane is given. Calculate weight of CO2 formed and also H2O formed. Use only POAC method ma. Don't balance the reaction, you just try. You take 28 grams, sorry, 28 grams. Yes. Any answers? So otherwise, sorry, take this 29 grams. For easy calculations, I am modifying these numbers, that's it. Take 29 grams. Yeah, any answer? If not, I will explain. You can do next question if you want. Okay, so check what we know. Definitely butane combustion produces CO2 plus water, but no need of balancing the equation. I am asking about weight of CO2 formed. What I should do? I should apply POAC on what? POAC on carbon atoms. Carbon atoms. How many carbon atoms this side? 4. So 4 into number of moles of butane, C4H10, which is equals to, this side how many carbons in CO2? 1. So 1 into number of moles of CO2 I can write. Okay. In the given molecular formula, how many carbon atoms are there? 4. So that's why 4 into number of moles of butane. This side. In this given molecular formula, CO2 contains how many carbon atoms? 1. So 1 into number of moles of CO2, which is equals to, so 4 into, what is the molar mass of butane? Like given weight by molar mass we should do. Why? Because question contains weight. So what is the given weight?
29 grams.
Okay, 29 grams. So 29 as it is. Yeah. In the bottom here, denominator. So butane na C4H10 is 58. 48 plus 10, 58. So which is equals to number of moles of CO2. So number of moles of CO2 I can write. This is 2 times. This is 2 times. So how many moles of CO2 produced? 2 moles. Done. We are almost done with the question. Now if I ask number of moles, 2. But I am asking weight now. So weight of CO2 by molar mass of CO2. Then weight of CO2 becomes 2 into molar mass. Molar mass of CO2 is 44. 2 into 44. So 88 grams is your answer for the question. Okay, right. In the same way, I know you can easily do now. Do it for hydrogen, oxygen, water. Do it for water. Yes. చెప్పండి ఎంత వాట్ ఈస్ యువర్ ఆన్సర్ ఫర్ నెంబర్ ఆఫ్ మోల్స్ ఆఫ్ ఆర్ ది weight of water formed for the same question? Done? Okay, let's try. So this is a question now. So no need of balancing again. How many hydrogens are there? So now we are talking about water molecule now. So water molecule needs hydrogens. Hydrogens are completely coming from butane only. How many hydrogens? 10. So 10 into number of moles of butane, C4H10, which is equals to this side. How many water molecule, hydrogens in water molecule? 2. So 2 into number of moles of water molecule. Clear how we are writing this? Okay. Then next, 10 into what I should do? Number of moles of butane given weight by molar mass. Given weight is 29, molar mass is 58, which is equals to 2 into number of moles of water. So this will be 2 times, this will be 5 times. Okay, number of moles of water will be now equals to 5 by 2. Okay, so if number of moles asked, this is your answer, but they are asking weight of water means number of moles into molar mass, that is 5 by 2 into molar mass of water is 18. So this will be 9 times, so 45 grams. Clear or not what we are doing? Okay, you can do any question related to POAC now, right? Got that confidence, or you want few more? Say something. Okay, we'll see. Amma, you try to increase your calculation speed. Okay, so first see, don't feel nervous. First of all, I'm not what I can say, I just wanted to give some suggestions, that's it. Okay, so first go with tables once again. Don't feel bad. First of all, go with tables. If you are not knowing calculations means tables, first of all 20 tables. Then next, once again, either take the help of Abhilash sir here, or you take help of Someone asking, sir, PYQ. Yeah, we will do PYQs only. But first let us have some clarity on these things. Okay. Now, in the previous class, I just discussed one basic question on this. I just wanted to mention here, you will solve it. Okay. Methane on combustion produces on complete combustion produces 54 grams of water. How many grams of water? 54 grams of water. Calculate weight of methane. Calculate weight of methane. See, today actually it should be like normally most like teachers, what they will do is they will only teach stoichiometric calculation like mole relation. I think if you have went already through the first year of syllabus, I mean in your last classes in previous anywhere in other institute and anywhere, they only taught about stoichiometry. Now I felt that you already know stoichiometric calculations. That's why I given this method. In the upcoming sessions we will cover stoichiometry. But you are clear with this calculation or not? PYAC method. Yeah, apply for this and do it. Do we require to write the equation also? Not required. Yeah, tell me how to do. Yeah, done? Say something, yeah? Okay, we will try here. So what I should do, tell me first. Methane producing water, this we know. Now complete hydrogens of water are coming from methane only. Now how many hydrogens here? 4 into number of moles of methane, which is equals to, here how many hydrogens? 2 into number of moles of water. Did we balance the equation? Did we balance it? No. Yeah. So next, N methane will be equals to 2 into water molecule weight. How much given? 54 by molar mass 18. So this will be 3 times. 18 3s are 54. Next, this will be 2 times. So number of moles of methane will be 3 by 2. Weight of methane will be 3 by 2. Down molar mass, now send that molar mass this side. So it will be 18. So it will be 9. So 27 grams. How many grams it is? 27 grams. That's it. Yeah, we'll do this once again if you want. How many hydrogens are there, ma? So 4 into moles of methane. Clear up to here. Next 2 into moles of water. Next 4 into this one. This side the data provided as 54 grams. Okay, 18 3s are 54. So 3s are done up to here. So next here 4 is there, here 2 into 3. So 2 cancel, we got 2 here. So it becomes 3 by 2. Moles of methane is 3 by 2. Next 3 by 2 into, okay. You should say here. So moles of methane is 3 by 2. Fine. Next, what I am asking? Molar mass, weight of methane I am asking. What I am asking? Weight of methane. So how to find weight of methane? Weight of methane by molar mass formula we know. Weight will be now number of moles into molar mass. So it will be 3 by 2 into molar mass. What? How much it is? 16 only. Okay. So it will be 24 grams. Okay. So just we taken it as 18 previously. Now it is 16. Correct? Everything correct? Yeah. See. Okay, next. Okay, you have books? Just, okay, give me. See, I will tell you some questions, you must do them. All questions from NCERT beginners from our module. Okay, then next, all questions means first 20 questions related to these concepts. Okay, next, exercise 2. First 7 questions. Exercise 2. Next, NEET PYQs. Just search. A few questions are there. Random questions. You can solve them. Okay. So tomorrow we will discuss about stoichiometric calculations and limiting reagent, excess reagent. Very important topic, ma. Okay, we will discuss this tomorrow. Even if I start now, it won't be completed. Yeah, that's it. We will wind up this session. If you have any doubts, you can ask.